All right. Thank you, everybody, for coming out tonight. I know it's not the normal night for the Node.js meetup, but I figured that it wasn't the best of ideas to go against the Develop Denver conference, especially since I was attending. So, before we get to the talk, I'd like to thank our sponsors. So for this space and for the drinks, we have Code Talent to thank. Is anybody from Code Talent here? Do you want to say hi? No. Okay.
I'm Nick.
Hi, Nick.
Hi, Nick.
Thank you.
Thank you for hosting.
Of course.
All right. And then for the pizza and salad, we have Google to thank. So, yeah. So, well, before we get to the speaker, does anybody have announcements that they'd like to make? Austin.
My company at Accelerant is looking for a software engineer, full stack, somewhere around mid to senior. If you'd like more information about it, I can go on, but just approach me maybe after or chat about it.
What's the company?
Accelerant. All right. We are live streaming this talk, which also records it for us. So afterwards, we'll have this talk available on YouTube. And also, this is a special edition of Node.js because we have two shorter talks today. So the first talk, I'd like to introduce Craig Freeman? Yes. Freeman. I was almost saying Feldman, but Freeman, he works at Twilio, and he's going to be talking about IoT stuff.
Great. Thank you. Thank you. So first, thanks for everyone for coming. Today I want to talk to you about a personal project of mine that I've been working on for a while. Pieced together a Raspberry Pi, a temperature sensor, using Node.js and Twilio functions to solve a problem that's very near and dear to me. But first, before we do that, I'll just give you a little background about me. So who am I? I'm a senior software engineer at Twilio, currently working on the Twilio SendGrid marketing campaigns UI. I've been developing for the web since around 2010 full-time, off and on since around 98. And I've been living in Denver since around late 2012, so not quite a native, but close enough, I guess. And no, I didn't move here for that. I moved for a job. So I haven't been at Twilio for very long. I got hired there in early June, and immediately they made arrangements for me to go out to their San Francisco headquarters and do this crazy 3 days of orientation. And I had heard some rumors about that, about having to present a project using the Twilio services in order to graduate the orientation. So just real quick for those unfamiliar, Twilio provides developer-centric APIs for communications, things like voice, text, chat, video, and email. And they also have some products that sit on top of those APIs. Just a quick show of hands, anyone using Twilio in an app currently? Nice. Okay, great. So typically when people ask like what Twilio is, I'll say the best example I can think of is like that text message you get from Lyft saying your ride is arriving soon. That text was triggered by the Lyft app and sent using the Twilio API. Cool, so anyways, in preparation for this orientation, I started thinking about a problem that I wanted to solve. And rather than coming up with a solution, I tried to think of a problem I've had to deal with recently and how it could be prevented using the Twilio suite of products and services. And I wanted to be proactive instead of reactive. I kind of struggled with this idea for a couple days, and it wasn't until I went downstairs to do laundry that I realized I've been dealing with a pretty large problem for the last 8 months at my house, which is my basement. It's not supposed to look like that, it's supposed to be finished. So quick story time. Let me give you a little context. Any homeowners here? Yeah? What would you say are some good outdoor maintenance tasks that you should do each autumn?
Turn off the sprinkler system.
All right to it. Some people might say like clean the gutters or rake and mulch, and maybe store some outdoor furniture, but winterizing a sprinkler system is also one of those really important ones. So for those of you that have lived here for a while, who can tell me about when the snow starts flying each year?
Anytime.
Fair answer. So I can tell you factually, it's going to be around October, November. The average date is October 18th, per the National Weather Service. So last October, I was out in Vancouver attending the Node.js Interactive Conference. I gave a talk on circuit breakers in Node APIs. My coworkers and I had a really fun time. It was a good experience, but upon returning home, the following weekend, Denver experienced a cold snap and some light snow flurries, which it does around that time of year. I got home late on Sunday night and had to return from work the following morning. Needless to say, I didn't really think much about my homeowner responsibilities then. I've lived in Denver for almost 6 years at that point, so I should have known better. So that night, October 15th, it got down to about 19 degrees. So you can probably see what's coming here. Following day, went back to work, caught up on a bunch of things, and in the afternoon, my neighbor texted me this gem. So that's the takeaway. You have water spouting in your backyard, which is like the worst thing you want to hear as a homeowner. So that's cool. This is the backflow preventer. Pressure vacuum breaker, there's a couple names, but spraying water against the exterior wall of my house. And the electrical box, which I noticed later, which is awesome. My best guess is that the cold snap froze water inside that thing that's spouting water. And then when the sprinklers turned on that morning, after I left for work, it broke the seal inside and water freely flowed out of it for about 8 to 9 hours. So to recap so far, I gave a talk on Node APIs and all I got was a flooded basement. So yeah, this single event led to about a year of water mitigation, flood cuts, carpet removal, asbestos tile removal, concrete pouring and sealing, foundation repair, like reconstruction, all sorts of fun stuff. This problem could have been really easily avoided if I had been more proactive in my homeowner responsibilities. I decided to build an IoT device that would alert me if the outdoor temperature started dropping below a certain amount to prevent all of that from happening again. So I started the project by finding the Raspberry Pi I knew I had lying around. I think I bought it on like a Black Friday special, never used it for anything. Needed to set it up as like a standalone computer, and since it only has one practical USB interface, I plugged a mouse into an old Apple wired keyboard and had a little USB hub on it, so I could like actually use it as a computer. I also ordered a bunch of cables, mini HDMI to HDMI adapters, micro USB to USB, that kind of stuff. I don't remember what that guy's for. I think it's the camera. If anyone knows it, say it so. But I didn't need it, so I didn't bother to learn it. So then next I created a bootable micro SD card of the Raspbian with desktop OS using Etcher on my MacBook. Put on a little micro SD card and it fit there in the slot. So I did a little bit more research. I ordered a suitable temperature sensor. This is the DS18B20 that I knew could be connected to a Raspberry Pi. And I also ordered some DuPont jumper cables to avoid soldering the sensor to the Pi, because I don't want to mess with that. Cool. So once all the pieces had arrived, I fired up the Pi and connected to Wi-Fi so that I could remote in using SSH or RDC. I tracked down another tutorial, just kind of pieced this thing together on how to use the temperature sensor, but I realized after I got everything together that the Pi model I had wasn't able to connect to the temperature sensor, and not having worked with any hardware before, I didn't really know what GPIO headers were or why I needed them. So really it's just the pins that allow you to connect the Pi to a sensor of some kind or other things. In this case, it was the temperature sensor. So did a little bit more research. Turns out you can't connect sensors without them, and I learned that there's a couple options for this. You can buy a header and solder them to the Pi, if you know how to solder. You can buy a hammer header kit to use with the Pi and install it yourself. Or you could just buy a new Pi with headers already installed for $14. So I did that. So running out of time, didn't really want to learn how to solder at last minute. So I went down to Micro Center and grabbed one of these guys. It was really nice. I could transfer the SD card into the new one, and it just worked. So I was back in business. So I made it this far without soldering. I continued to do so using the DuPont cables to connect all the pieces that I had. So the jumper wire connects to the sensor board. That jumper wire connects to the DuPont extensions, and then the extensions attach themselves to the headers on there. And there's power and ground that is kind of a known for these GPIO headers. And then using the tutorial, they helped me kind of figure out which pin I needed, because that would have been a lot of trial and error otherwise. Cool, so I let the Pi boot up, and per the tutorial, I edited the boot config file and added this new sensor at the right pin to register with the Pi as a volume, so I could mount it on boot. Tutorial I had showed how to read the sensor using Python, but I don't know Python. So I ended up installing Node version specifically for the Pi's ARM v6L processor architecture. Just quick side note, Node version 11.15 I think is the latest that I could find. I don't know if they have version 12 for this particular Pi, but cool. So quick note on the code. This is more or less my controller kind of handling all the different pieces. So it hands data from each of the utilities. It pulls for sensor data every so often. And when the temperature received is at or below a threshold, the app will report the temperature. Can everybody see that? It's not super important. The things in bold are kind of the important things that I'll get into here. So yeah, the get sensors, really, I wanted to make this flexible. It's not probable that I'll have more than one sensor at a time. But just in case, I made it flexible. So that's getting the sensor, and then I wanted to read the data from the sensor. So just go and read that file at that volume, and then return the results. The parse data is just taking that data and making it either Celsius or Fahrenheit, so that it's not like some confusing number from the sensor itself. So once that was working, I had to wire up the reporting to a Twilio service. The app makes a request to a Twilio functions endpoint, which is basically like a serverless function or Lambda with the Twilio context already part of it. So it sends data from the Pi to the predetermined phone number via text message. To do this, I had to obtain a phone number from Twilio and use that as the from value. So that is just the environment variable there. So finally, I created the bridge between the app and Twilio using this report temp function. So when called, this will make a request to that Twilio functions endpoint. And it works. Surprisingly, lots of trial and error involved, but I just then had to present at the orientation. So once I got there, I realized I didn't have a monitor or keyboard to like get on the Wi-Fi. But thankfully, I was able to like type in the Wi-Fi credentials using SSH from a Wi-Fi router that I had. But at the orientation presentation, I didn't have that accessible. So thankfully, I had the Wi-Fi plugged in already. I considered doing this remotely from a laptop, but because I didn't have there was an issue with the Wi-Fi where I couldn't SSH from the same network, couldn't find it for some reason. So a colleague suggested I use an application called ngrok, which basically creates a publicly accessible SSH tunnel with like a randomized port, so it's semi-secure, which was pretty much what I was looking for. So I edited the WPI supplicant on the Pi to prioritize the Twilio guest Wi-Fi. I added ngrok as a service to be run via systemd, so whenever I plug this thing in, it would just start up and connect to ngrok against the ngrok config I had set up. So I could now just type in SSH Pi at whatever the URL they gave me, and then type in the right port, and that connects me to my Pi, which is great. Cool. So that's sort of the background here. I wanted to give a demo of this, just try it out. So here's my little device here. In theory, it's going to be hanging out outside, so I wanted to be semi-waterproof. So in here, I've got the device, which I just need to power up real quick. Give me a sec. Cool, so that's going. It might take a minute for this to, load everything up and connect to ngrok. So let's do this real quick. This is really weird to do backwards. We're just going to keep refreshing until it shows up, which is super interesting. So everyone's cool? Everyone's good? Anytime. It does work, I promise. Yes?
What's the operating temperature range of the Pi?
I could not answer that, I'm afraid, but I'm happy to look it up with you later.
No, I can look it up. You said you were going to put it outside, so I thought.
That's a good question. That could be a problem, but I haven't gotten that far. This came about in around June, so it wouldn't really have those concerns then.
Actually, you do, because there's a high temperature range. High temperature.
Oh no, where I was putting it would have been in the shade. I would have made sure. Yeah, no, these things would have melted in the sun timber. Cool. So we got our tunnel. It's 0. Yep. There's that guy in there. Great. Nobody look. All right. So I set this up so I could pass in a bunch of variables into the command line here. So I'm going to set this to 45 degrees. We'll poll every second or so. Oh, that's not a second. And then I'll report every minute. Let's get this going. Cool. So we're polling. I got this fun little glass here. I got my sensor, so we're just gonna put that in there. Watch it do its thing. And then at some point, it'll get below 45, which now reported, and I just got a text message. And that's it. Cold snap, current temperature is 45 degrees, which is at or below your threshold. And I'm going to keep getting that every minute. So that is it.
How do you monetize that?
I have a feeling it's already been monetized somewhere else. So just quick recap. This was a really fun kind of project to piece together. I knew nothing about Raspberry Pis going into this. Learned quite a bit about Node on the Pi. How to connect a temperature sensor, all sorts of fun stuff. But in retrospect, I think setup would have been slightly easier with like a better Bluetooth kind of keyboard and mouse type thing. ngrok was a lifesaver, but I still needed to know the Wi-Fi, which was tricky. So although Node, oh, I had things to click through that I didn't. Yeah, so although Node indirectly caused this, it'll also prevent it from happening again. So cheers to Node, the cause of the solution to all of life's problems. And that's it, thanks.
Are you going to do questions?
Yeah, anybody have questions? Sir.
I'm actually curious, I wanted to take you to build out that.
Which part?
Like, the whole thing.
The whole thing? The question was, how long did it take me to build out the whole thing? Start to finish, it was probably 2 weeks between all the different Amazon deliveries. Yeah, it wasn't terrible. I mean, it was a lot of Googling and trial and error, I have the GitHub up here if you guys want to see how it's functioning with the Node code. I have the resources up, so yes.
Is there a max number of requests for like sending out the message to your phone, or do you know?
From Twilio?
Yeah.
I don't think so. There probably is. I've never gotten that high of a scale, so okay. I don't worry about it. But it's a Lambda function, probably with AWS under the hood. So, you know, the world is your oyster, I guess. Yeah. Someone else have a sir?
How many times did you have to see the temperature below threshold before you do something?
I think it's just the first time.
So you don't have to require the poll to show below for a certain number of samples?
I don't.
Okay.
It's all in memory, so I mean it'll keep track of how many times it gets that number within a certain time span. So if it's polling every second, and I have the reporting set to like a minute, it'll hold off the reporting until that minute has passed. Yeah. Yep.
How much does the last cost?
That's a good question. I mean, the Pi was probably $15, $14. The cables were probably another $6. The temperature was maybe 10. So I mean, less than 50. I think the case was probably the most expensive part. Yeah.
I didn't quite understand how you're calling the Twilio functions. Was there an API gateway for that?
There was not. No. So anyone could just go hit that right now, which is why I covered it up. But there are gateways that you can put in front of that. Yeah. Cool.
All right.
Awesome.
Thank you, Craig.
Thanks. Too many things. So we'll have to leave that there.
Yeah, sure, it's fine. Okay, for our next speaker, we have Marlena. She gave this talk at Develop Denver, so if you didn't go, this is a special treat for us. Marlena is a developer at Quizlet now?
Home Advisor Connect.
Home Advisor. Sorry, I keep on forgetting who everybody works at. Home Advisor, and you're going to be talking about debugging. So let's give it up for Marlena.
Let's see if this goes.
I got it over there. Let's see if the projector likes us today. There we go.
Sweet. Thing? You did the thing. Cool. Hi, everyone.
How's it going?
Hi. What are you doing back there? Of course. So, quick show of hands. Who here remembers anything at all about the immune system from like probably middle grade science? Anyone? I see a little. Huh?
Remembers about what?
The immune system. A few hands, a few wobbly hands. I mean, pretty much the same, right? I had to do some research for this talk, and while doing so, I discovered that we have advanced our understanding of the immune system quite a bit. But don't worry, we're going to stick to the basics. I'm going to cover what you need to know, and we're going to stick to like the most common or most well-known immune system. So to protect us from illness or bugs, our immune system needs to be trained. That's our adaptive immune system. It's what most people recognize. It does so by encountering bugs and then building defenses against them. I see some looks of confusion. It's fine. It turns out our code also has an immune system, an entity that will find and remove bugs. But that entity needs to be trained as well. So let's talk about how to strengthen your coding immune system, aka how to debug smarter. My name is Marlena Baker. This is me pushing up some perfect code. I'm a front-end developer at HomeAdvisor. I am an education enthusiast, a cat and snake mom. Isn't he cute? Anyways,
What are their names?
huh?
What are their names?
The cat is Alex and the snake is Monty. Yeah, that's my husband's fault. I am also a distractible crafter. I have about 10,000 hobbies. You can ask me about any of them, but I will talk your ear off. And I am a co-organizer of the Denver Vue.js meetup. I see at least one familiar face. We actually meet next Monday at HomeAdvisor, right down the street. And we're going to be talking about accessibility and the Focus pseudo class, so check us out. All right, but today we're going to be talking about immune system behavior, encountering new bugs, dealing with bugs in the future, and then when you need outside help, because we all need it eventually, right? Let's start with immune system behavior. Fully functioning immune systems are decent at knowing what doesn't belong. Oh, there we go. But it takes time to learn the difference between what should be there and what shouldn't. The same thing is true of your code. The first important piece of information you need for proper debugging is to know your code. And that might be really easy if you wrote the code, but if you're helping someone debug, if you're in an unfamiliar code base, take a moment, take the time, and read through and understand at least on a high level what it's supposed to be doing, because if you don't know what it's supposed to be doing, you certainly won't recognize when it's not doing that. Being able to evaluate code as you read it is a wildly valuable skill that I cannot recommend enough. Even if you aren't familiar with the language, you can usually pick up some similarities. You might be able to ask another developer to help you gain that understanding, or ask every developer's best friend, Google. You're also going to need to pay attention to the warnings your code gives you. They're red, they might come in quick succession, they might never stop if you started an infinite loop. I have done that multiple times. But don't be afraid. Errors are there to help you. If you stop and you look at them, they'll give you some useful information, like what type of bug it is, potentially what file and line number. Even the stack trace, as intimidating as it can have some useful information in it. You're also going to want to pay attention to symptoms, or the strange behavior that your app is presenting to you. There's plenty of errors, especially in JavaScript land, which is where I live, that don't actually throw errors, but are still very broken. So I'll think that my code is totally fine, and then find out that I'm not capturing user input, or HTTP request just doesn't work. That button click doesn't do a damn thing. Those are fun. So those are kind of the signs that you'll be looking for that something's wrong with your application. So what do you do when you encounter a new bug? Well, our immune system doesn't just magically know what that bug is and how to deal with it. It has no idea that it even existed until it appears. Your immune system takes some time to encounter the bug, figure out what defenses it needs to build. Help.
There's a bug in it.
I love how the
Maybe I should have airplayed.
It's back on a stream again, so I
Oh.
just gotta press the source button.
Okay, I see. I will remember that if it happens again.
It's gotta
That was
take-
my talk in a nutshell right there. If it happens again, I know what to do.
There, we're back.
Thank you very much. So when it runs into a new bug, your immune system needs to study it and develop defenses, otherwise known as antibodies, to protect against that particular bug. Then the next time your immune system encounters it, it knows what to do. And we have to do the same thing. To effectively debug, you have to pay attention to the bugs that you encounter and learn about them. Bugs cause a lot of stress and frustration, especially if they keep cropping up, if you have a deadline, if you just keep beating your head against this one thing that won't go away. But every single bug you encounter is a learning experience, and these are some ways that you can learn from them and become better at debugging. So the first thing that I'll recommend you pay attention to is the type of error. This is one of those helpful hints that the error messages give you. Like reference errors and type errors have pretty distinctly different causes, typically. And keeping the type of error in mind as you look for the bug will help you evaluate if a block of code is likely a culprit, and in the future will help you understand similar types of errors. My favorite is when I have misspelled the same variable 2 different ways when I reference it and when I declared it. It's great. I can't spell it to save my life. Also, the symptoms of the bug will tell you a lot. What behavior does it cause? That could be a valuable clue if your error message doesn't give you enough information, or if there's no error message, like I often run into. I had a super weird bug when I was learning to code. So I was making a timer. I was brand new to this, so please understand that I had no idea what I was doing. And I was writing this timer, it was accepting the user input, and then when I clicked the button, it was counting down a second and then zeroing out. It was also creating an infinite loop, but I don't want to talk about that. It's traumatic. So I was so lost. Like, why was the input there? Why did it even appear to work and then just fail? I was ready to give up. Luckily, with some help, I was able to figure out the bug. And it was a kind of a typical timer, right? Like, accept the user input, set a set interval. After seconds are out, like, clear the interval. Hang on. Assuming it comes back up, I know what to do.
Probably have to point it at the projector.
Huh?
I think you have to point it at the projector.
Well, I think it also needs to do that. Oh, shoot. Which HDMI port is it? Not that one.
Oh no, it's. I think this thing is.
That thing's causing it?
Yeah. The dongles are always questionable.
Always blame the dongles.
Oh, it's just part of debugging, right?
Yeah, no, this is like very in line.
There we go.
Yeah.
Cool, we're good. Every time we get a little better at this, right? Anyways, so eventually I figured out we're still in the timer story. I probably could have talked without this, but I wanted to figure out what was wrong. When I was checking to see if the seconds left equaled 0, does anybody want to guess what I was doing?
Restart.
Huh?
Restarting it?
Restarting it, you're on the right track. I had one equal sign. I see some realization. I was assigning the variable to 0 rather than checking whether it was 0. Very rookie mistake. I've been very good about my conditional since. So this is how symptoms can tell you a lot about an error. Question?
Have you learned to use a linter since then?
Huh?
Have you heard about linters?
I have, in fact, started using linters since then.
Because I've had the same problem. Since I switched to linters, I no longer have.
Oh, linters help immensely. So they'll catch me if I misspell it 2 different ways, but they won't catch me if I misspell it the same way. Then my coworkers are like, so it's fine, but you totally misspelled this. Great code review comment. All right, you should also pay attention to the cause. In my code, this means a misspelling a lot of the times, but knowing what the error apologies. Knowing what the error you fix now is will help you a lot in the future. When you encounter similar errors, you'll be like, oh, I know what this is. I watch my conditional expressions a little more carefully now. And another bug that comes to mind is incorrect binding of this. If your context is bound wrong, you get a lot of really dumb errors. Oh, I don't like you anymore. Maybe I'll just airplay this time. What do we say? You're helpful. Code big screen would be my guess.
All right, you do emergency switch to airplane mode.
Yep. 5, 4, 6, 2. Okay. Oh, extend, please. Like, I know this talk, but I don't know this talk that much. Okay. Please? Where did you put it?
I mean, it's going on in a stream, so.
Okay, no speaker notes. This is gonna go so much better now. All right. So once you encounter an improper binding of this or your context, it's really easy to spot those kinds of causes because they have very distinct, they cause very distinct issues. And so knowing that cause is really helpful. You can also learn a lot by paying attention to similar types of bugs. So if you keep getting reference errors, you're gonna start figuring out, oh, like I've messed up a variable somewhere. This reference error is a lot easier to debug now. Sometimes the cause of bugs will be really obvious, like such and such variable is undefined. Sometimes you have to do a lot of experimenting, like with the improper this binding. So you're going to need to experiment with your code, and you're going to learn a lot from doing so. Like, it's frustrating at first because you're trying things, and your errors are still cropping up. But everything that you do, especially small changes, by incrementally making small changes, you can isolate behavior to specific lines of code, specific changes that you're making, and say, oh, this particular thing caused this particular error, which causes this particular problem. And by doing that, you gain a lot of knowledge about how your code works and how errors present. Which brings us to the final and possibly most important step, record it. It is not unusual to have a record of errors that you encountered and how you solved them. That's basically what Stack Overflow is, and we all love that dearly, don't we? A notebook or a note-taking app if you're working on something alone, or something like Confluence or a Drive if you're in a company. That way you can all pull your debugging solutions together and have a catalog of errors that are common to your code base. It's so helpful. It will help everyone out. It will help new people the most. And I highly recommend that you do it. This is your antibodies. This is your immune system building that defense against future bugs. So let's talk about how you're going to deal with bugs once you have it. When your immune system has antibodies, it can race over there, deal with a bug really fast. If you get sick, it'll be mild, but a lot of times you won't even get sick. So you had the flu for a week and a half and it sucked, but then you're not going to get the flu again. When you have these coding antibodies or this knowledge base of common errors, you can do really awesome stuff like not include them in your code. Like, I tend not to accidentally assign variables and conditionals anymore. It's really cool. You will be able to identify the issue much more quickly because you've seen it before. For me, a lot of times it's like, if I see an error that says that it's on line 52 of this file, but there's only 30 lines in the file, I know you're probably missing a bracket or parenthesis, because that's usually what causes this weird, like, I don't know what's going on error. And you'll be able to hone in on a solution much more quickly. Sometimes my coworkers will ask me over to look at a bug, and I'll know what the problem is before I've even looked at their code, and I know how they're probably going to fix it. This is the result of messing up a lot. It's really, really helpful. And if you come across similar bugs, even if you don't know them specifically, you're likely to know a little bit more about them than if you had not run into all this broken code before. And my favorite, I just mentioned it, helping others. It's sometimes frustrating, but often, pretty much always very rewarding to help someone get unstuck and remove a bunch of frustration from their day. I personally love it. But what's important about this, we're all problem solvers and we all see an issue and want to be like, fix. But what you really should be doing if you're going to use this knowledge forward and help others with their bugs is to guide them to the solution so that they can start building up their own antibodies about it, so they can start building up their own experience with bugs and hopefully be able to solve it for themselves in the future rather than having to slack you again. So let's talk about when you need outside help. Your immune system has limitations. Sometimes bugs are particularly strong or are resistant to your immune system. Sometimes it's your own body attacking itself, which is not so fun. And sometimes the problem lives outside of your body, and your immune system can't really deal with the cat. If you've been doing this a long time, you're probably not looking for outside help very often. You've got a well-developed sense of how errors behave, or even if you haven't been doing this a ton of time, you've just really messed up so much. I can't overstate that enough. And you have a good sense of what errors are typically going to require what solutions. Sometimes you have really good control over the environment your app runs in, and so you can just go fix that yourself. Most of us don't have that, and we need to reach out because we have been beating our heads against this for an hour, and if we do it any longer, we're going to go crazy, throw our computer out the window. Or maybe those environmental things are under the domain of DBAs or DevOps or a vendor, and you can't go fix that problem yourself. So fun environmental issues include your database being down, a microservice that you call out to belongs to another team and you're going to have to negotiate with them about when they can fit it into their sprint, my favorite. Or the cloud is just on the fritz and you're like, Cloudflare, help me. These kinds of bugs definitely do happen, and you can't always fix them yourself. You're reaching out to someone else. What I want to emphasize here is that it's still important to pay attention to the things we talked about before in the purple section about dealing with new bugs. Knowing what symptoms you see, what errors you see, and what the cause was means that the next time that Cloudflare has a problem, you know exactly what symptoms mean it's Cloudflare that we need to go talk to, or even if you're not sure, you're more likely to go look there than previously. So it still helps you figure out the issue and reach out to the people that you need to reach out to faster. So all of this is really cool stuff, but there's a really key component. I've talked about it several times, probably, but I'm on my soapbox now. Run your code. Really cannot emphasize it enough. And this is the Node.js meetup, so hopefully we're all in the happy position of being able to rerun our app in about 10 seconds. My backend devs who are working in Java are like, okay, I'll run my code, but let's talk in 15 minutes. But even if you have code that you think is perfect, like the code that I definitely write, run it. Make sure that it works. See what happens. If you're not sure about your code, definitely run it. See what this thing that you're experimenting with actually does. And if it throws an error, that will help you figure out what your next step is because, oh, it's a reference error. I've got an idea now. Run it as often as you can. Isolate changes to your code to better understand what it does. I know I sound super repetitive right now, but really, this is my biggest tip to you tonight. If you walk away with anything, it should be this. Run your code. You will learn so much from it. So, we talked about immune system behavior, encountering new bugs, dealing with bugs once you've got that awesome immune system going, and when you need outside help. And of course, to run your code. These tips will help you debug just about anything and help you get better every time that you do. So keep building, keep messing up, and keep learning. I'm terrible at social media, but I exist at Twitter, GitHub, LinkedIn, and of course the Denver Dev Slack channel. Slides are on my GitHub. Thank you all very much. Any questions? What do you got for me? Yeah.
I'm actually curious what the stack you guys use at
Home Advisor is using Vue.js on the front end, Java Spring on the back end, and Oracle DB. All right, thanks you guys.
Thank you.
I need to actually tell it not to airplane anymore. I got so used to the game.
All right, that's it for our talks tonight. We have the space for about half an hour or so. So thank you everybody for coming out, and we'll see you next time, which is going to be on a third Thursday.